In April 2026, a newly found comet designated C2025-R3, frequently referred to as Pan-STARRS, is set to travel through the inner solar system. Early data indicates it has the potential to be among the brightest comets we see this year. While scientists are remaining careful, given how notoriously difficult it is to predict comet behavior, its specific timing and path have made it a priority for observation, particularly following several impressive comets in the last few years. In this video, we're going to look at the current astronomical data, explore why predicting its brightness is so difficult, and discuss what skywatchers can realistically look forward to as it draws near. Let's dive in. Discovery. Comet C2025-R3 was first spotted in September 2025 during standard survey work by the Pan-STARRS system in Hawaii. Much like other modern finds, it wasn't a standout object visually at first. Instead, it was flagged by automated systems that noticed a dim object shifting slowly against the backdrop of stars. Follow-up tracking confirmed the object was a comet moving along a highly stretched, long-period orbit. This classification immediately made the comet a subject of scientific interest. It is believed that long-period comets hail from the Oort cloud, the solar system's most distant outer reaches. These bodies can drift far from the sun for tens of thousands of years before a gravitational nudge sends them inward. For many of these objects, a trip through the inner solar system is a once-in-a-lifetime event. Calculations show that C2025-R3 will reach perihelion, its point of closest approach to the sun, on April 20th, 2026. At that moment, it will be positioned between the orbits of Venus and Mercury, subjected to intense solar radiation. Only a few days later, on April 27th, it will pass relatively close to Earth at a distance of roughly 70 million kilometers. This specific timing is important because a comet's brilliance is a product of both viewing geometry and solar heating. Nearness to the sun triggers activity as frozen materials sublimate, venting dust and gas, while proximity to Earth makes that activity easier for us to see. When these two factors align, a comet has a much better shot at being truly visible. However, geometry isn't everything. Many comets with great orbits never brighten up, either because they lack volatile materials or their nuclei simply don't react much to the heat. At this point, the trajectory of C2025. The primary question regarding C2025-R3 is exactly how bright it will get as it nears the sun. Current projections cover a broad spectrum, ranging from a dim object only visible in binoculars to a comet that might be seen with the naked eye under dark sky conditions. This uncertainty is normal and highlights the difficulty of forecasting comet activity. Unlike solid asteroids, comets are dirty snowballs, loose collections of dust, ice, and volatile compounds. As solar heat warms the nucleus, these ices turn to gas, dragging dust along to create the tail and coma. This process varies wildly from one comet to the next, and is nearly impossible to predict before the activity is well underway. Currently, brightness estimates for R3 range from magnitude 8 to as high as magnitude 2.5. At magnitude 8, it would be easy to find with a small telescope but invisible to the eye. At magnitude 2.5, however, it would briefly rival some of the brighter stars in the sky. One element that might boost its appearance is forward scattering, which occurs when the comet passes between Earth and the sun's sunlight can bounce off dust particles in the tail and be redirected toward us, creating a temporary surge in brightness. This effect has made past comets much more spectacular than expected. However, this depends on the comet being dust-rich. A comet that is heavy on gas but light on dust may look great in scientific instruments but stay visually dull. Beyond its beauty, this comet is a scientific goldmine because of its origins. Long-period comets are thought to be time capsules of pristine material from the early solar system. As R3 becomes active, spectroscopic analysis can identify the gases and dust it sheds, allowing researchers to compare it to other recent comets. Regardless of whether it puts on a dramatic show, C2025-R3 will provide critical data that helps refine our models of how these ancient objects form and evolve. Implications and what's next. As we move further into 2026, the predictions for R3 will shift from math-based models to real-time measurements. Astronomers will be monitoring its gas production, tail structure, and coma size very closely. These observations leading up to perihelion will give us a much clearer picture of how the nucleus is holding up. For skywatchers, it is vital to manage expectations. Even if it reaches naked eye brightness, your view will depend on light pollution, atmospheric clarity, and the comet's height above the horizon. Many naked eye comets are actually quite faint and require a bit of effort to spot. However, the calendar is on our side. The moon will be in its new phase just before perihelion, which means moonlight won't interfere during the most critical viewing window. Because the comet is moving through well-known star fields, observers should be able to track its progress over several nights. If it stays intact and produces enough dust, it could be one of the year's most memorable sights. If not, it will still be a great target for those with binoculars. We also have to consider the possibility of the unexpected. Some comets break apart or fade away as internal stress builds up. While a fragmentation event might ruin the visual show, it is scientifically fascinating, showing just how fragile these bodies are. Ultimately, C-2025 R3 arrives at a time of high public interest in astronomy. Whether it becomes a great comet or stays a modest one, it will continue this era of active observation and help us better understand the travelers from the Oort cloud. OUTRO. Comet C-2025 R3, Pan-STARRS, has a very promising path, but the final verdict on its brightness is still out. As it nears its closest point to the Sun this April, we will finally see if it becomes a visual masterpiece or a quiet visitor. In any case, it's going to provide us with incredible new insights into the nature of long-period comets. Enjoy the show. Moving into 2026, the discussion around Comet R3 will transition from speculative models to actual data. Astronomers will be tracking its magnitude, the scale of its coma, and the development of its tail in real time. These observations, especially in the final months before it reaches perihelion, will offer a much clearer window into how the nucleus is reacting to increasing solar heat. For those planning to watch from home, it is important to keep your expectations in check. Even if the comet officially reaches naked eye visibility, what you actually see will depend heavily on your local conditions. Things like light pollution, horizon haze, and how high the comet sits in the sky can drastically change the experience. It's worth remembering that many comets labeled as naked eye objects are still quite subtle and often require a bit of practice to spot. That being said, the calendar provides some helpful advantages. The moon will be in its new phase just a few days before perihelion, which removes significant light interference during a vital observation period. Since the comet will be traveling through easily identifiable star fields, observers should have a good opportunity to track its journey over several mornings or evenings. If R3 turns out to be particularly dusty and stays in one piece, it could easily become a highlight of the year. If it behaves more modestly, it will still remain a great target for anyone with binoculars or a basic telescope. From a scientific perspective, a global network of both professional and amateur astronomers will be watching. This kind of teamwork is the backbone of modern cometary science. While professionals gather high-end spectroscopic data, amateurs provide the frequent, long-term monitoring that tracks day-to-day changes. Of course, comets are famous for surprises. They can break apart, dim unexpectedly, or suddenly flare up as internal pressures mount. While fragmentation might be a letdown for casual viewers, it is incredibly useful for scientists, as it reveals the fragile structure of these ancient bodies. Ultimately, C-2025 R3 arrives at a time of renewed public fascination with the night sky. Regardless of whether it becomes a legendary sight or a quiet visitor, it will help us sharpen our understanding of these long-period travelers. OUTRO. Comet C-2025 R3, Pan-STARRS, currently sits on a very promising path, yet its final brilliance is still a mystery. As we approach that April 2026 perihelion, we will finally see if it lives up to the hype or remains a modest target. Either way, it is set to contribute essential new information to our study of the outer solar system. Enjoy the view. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.